Okay, going on now to topic 2 of chapter 3, solving by substitution or elimination. And we're going to now feature two methods of solving systems of linear equations. But I'm going to give you a little background before we go on. Now, in section 1, we did graphing. So if the line of our graph falls right over the grid line, then you could pick that out pretty well, whatever that point happens to be. But if they intersect in some point away from the grid line, then these are not whole numbers. So this is sort of like maybe, I don't know, 0.8 here, this way, and it might be like 0.7 up, so maybe, I don't know. So if this were the origin here, this ordered pair would be like 0.7 going over, or maybe, no, maybe not 0.7. Maybe this one's 0.8 and that one's 0.7. So this would be the 8 and this might be the 7. I don't know. Anyway, it's kind of hard to tell. But here, this one, if this were the origin, this would have been 0, 1. Nice whole numbers. But that isn't always the case. So where graphing is good to illustrate the sort of thing that's going on, where you're looking where one line will intersect with another, if it's not over a grid point, it's hard to read. So there must be other methods to do it. And there are. And one is called the substitution method, and one is called the elimination method. Now in class, we actually went over the different methods and showed you. So let's give you a little, again, background on this. So one of the things they tell us to do is to carefully see, is each equation in standard form? Well, this is in standard form. This is in standard form. Now, if we put a line under them and then add them up, what happens? Well, here we get 8x. But here, because they're opposite signs, the y's are just going to cancel out, and that's going to equal 10. So the choice of what you would do for number 1 is use the elimination method. And we're showing you part of that. Now, they're not asking us to solve it. They just say, what method would we use? Now, as we look at number 2, this is not in standard form, the second one. The first one is. But notice what we have here. We have, in this second equation, we have y equals this. This is what y equals. So if we take this value for y, 4x minus 7, and then rewrite this equation, it becomes 6x plus, and there's our y, and we say y equals 4x minus 7, and that equals 9. We have, through the process of substitution, gotten rid of one variable, the y variable. And now we have an equation with only one letter, the x. And that's what we want to do. So for the first one, we had them in standard form. We put a line under them. The two y's canceled out, and we have just 8x equals 10. In example 2, we use this value for y in terms of x to replace the y, that is, to substitute for the y. And again, we get an equation with only one variable. Now in example 3, here this is 6a minus 3b. Notice this is 2b minus 6a. So if we just put this second equation here in standard form, notice what happens. Now, if we put a line under this and add them up, the 6a's cancel out, and we're left with b, a negative b, equals 8. And we already have one value. We know a negative b is 8, so a positive b will be a negative 8. So we have one of the values. And how did we do it? We used the elimination method by being sure they're in standard form. Now in example 4, they're already in standard form. We're wondering, what could we possibly do to eliminate one of the variables? Well, notice here we have a negative 4t, and here we have a positive 2t. Well, if we could increase this one to make it a 4, the 4's would cancel out. So what we do is we put brackets, put a 2 outside, and then multiply each term, making this a different equation, but equivalent, so that now the 4t will cancel out. And then we get 11s. These cancel out, and we get equals 27. Now, notice this one is not the same equation anymore, but it's equivalent. And we're authorized to do this. So for example 4, we would use the elimination method. Okay, that's all they wanted us to do for these. Now, as we do these next few, they're asking us to use, in this case, the substitution method. And for number 6 as well. So rather than making the tape too long, I'll set this up because it takes me a while to write them out. Okay, the key to this is that you want to have either the x or the y equal something all by itself. So here we have a y equals this. So we then take this into the other equation right here. I went a little bit too wild on that. Right in here. And so the y value is replaced there. We use the distributive principle to get rid of the parentheses. We group like terms. We transpose the 12 to the other side. It becomes a negative 12. And 5 give us a negative 7. Divide both sides by 7. X is a negative 1. And we put that up over there. Now, this equation, you could use either one. I chose this one. Want to find out what y is. So where the x is, I put the negative 1. 2 times negative 1 is negative 2, plus 6 is 4. And the method I used to solve for this was substitution. By finding either the x or the y, here it was a y, and then using this value in the other equation to replace the letter. And there's the work. Now here we didn't have s by itself. So I transposed the negative 6t and got a positive 6t plus 5. Now I'm going to use this in my other equation for the s. So this was 3s, but now I'm using this value for the s. I'm substituting, getting rid of the parentheses, combining like terms. I get 20t, transpose the 15, get a negative 15, divide both sides by 20, and then simplify. I get t is a negative 3/4. Now there's quite a bit of chapter 1 in here for solving equations. Now I have a negative 3/4 for my t. So I'm using that first equation, or this one here. S equals 6 times RT, a negative 3/4. And I simplify. I cancel out there. This becomes a 3. This becomes a 2. So I go 3 times negative 3 gave me a negative 9 divided by 2. And then since I have to combine fractions, I made my positive 5 into 10 over 2. This is 5 in another form. Now I have negative 9, positive 10. I end up with a 1 over 2. So my other point is 1/2. And that checks out. What method did I use? Substitution. All right, in doing these, again, we're using substitution. So here x is equal to this. So I write my other equation, 3y minus, now what did we say x was equal to? This right here. But I have to put it in parentheses because I have to change each of these signs. So this becomes a negative 3. This becomes a negative 4. Now notice what happens. These cancel out. And I'm left with a negative 4 equals 5. Is this a true statement? And the answer is no, that's not true. When you use this method, whether it's elimination, which we'll do later, or the method we're using now, substitution, and you get a not true statement, then the answer is no solution. And why? Because these lines are parallel. And mathematically, this is how you arrive that they're parallel, because there are no solutions. If you were to graph them, they would graph as parallel lines. All right, number 8. Again, we have b equals this. So in my first equation, I write 6a minus 2b, and where the b is, I put in my value for b. I'm substituting. And I write the 6, of course. So I distribute, and I get this. Notice you had to change signs here. Now notice again, the a's are canceling out. And I get the statement 6 equals 6. Now if I subtracted 6 from both sides, I'd get 0 equals 0. But I could stop here. Is 6 equals 6 a true statement? As is 0 equals 0, by the way. And the answer is yes. When through mathematical means you end up with a true statement, the answer is they're the same line. So we would use our set builder notation, or in this case it's A and B. A, comma, B is such that, and you could write either equation down, 6a minus 2b equals 6. That is, these are the same equation, just hidden a little bit in algebraic terms. But we found out they were the same when we substituted, as we have the work here, and we ended up with a true statement. Okay? We'll focus on these one at a time. We're now going to use the elimination method. Notice they're sort of in standard form. When you write them right underneath. Notice if you add these two up, they cancel out. So adding these up, I get a negative 2x equals 6. Divide both sides by negative 2, I get x equals negative 3. And I'm going to put that negative 3 right there where the x is. There it is. So negative 3 times 3 is negative 9. Minus y equals 3. Transpose the negative 9, makes it a 12. Negative y equals 12. And I'm going to divide both sides by 1, or just change the signs. There's my ordered pair. Now, in example 10, they're in standard form, and nothing seems to cancel out. So here's where we have to use a little bit of artisan, a little bit of smarts, so to speak. We want to get one of these terms to cancel out. Now, if I multiply the 12b by a 3, that'll make it 36. And if I multiply the 9b by a negative 4, that'll make that a negative 36. So that's what this is indicating. I've decided to multiply all the terms of the first equation by 3. That makes it 24a plus 36b plus equals 30. Now it's important to note the technique. You've got to multiply every item. And then the same here. Negative 4 times 6a. Ooh, that's giving me a negative 24a. And this is what I was looking for, a negative 36b. And I end up with a negative 20. Well, these are going to cancel out. These are going to cancel out, and I end up with a 0 on that side. And 10 over here. Now, is that a true statement? No. So, for this one, there is no solution, because these lines are parallel. How did we figure that out? Well, we modified the equations to make them equivalent equations so that at least one term would cancel out. Here we had two terms cancel out, and we got a not true statement. And when that happens, there's no solution. Now I'll let you see some of the thinking here for number 11. Here we see it's in standard form. Nothing's going to cancel out. But if I multiply my 5r by 2, that'll make it a 10r. If I multiply the 2r by a negative 5, that'll make it a negative 10. So let's do that one. So this is going to be a 10r plus 16s equals 10. And this now will become a negative 10r minus 10s equals a -5. I put my line. These now will cancel out. I've eliminated the r's. So this becomes a 6s, and that equals a 5. So this gave me some fractions here. I saw that coming. So s is 5, 6. I then put 5, 6 into this second equation up here. That canceled out, and I got a 5/3. Brought that over, converted the 1 to 3/3. I got a 2r equals a -2/3. Had to divide both sides by 2. And when I divide by 2, I change it to its reciprocal. Here the 2's cancel out, and I get a -1/3. Again, I'm not going to give you these rather difficult problems. Most of ours will be whole numbers. I'm going to try to be sure we do that. Okay, one of the things, set them up in standard form. I had to move this 4y over here. And then I said, well, wait a minute. If I multiply this top by a 2, a -2, it'll change the signs. But notice what happens. I end up with exactly the opposite. So this cancels out, this cancels out, and this cancels out. In fact, if I had multiplied this by a +2, I would have seen I've got exactly the same equation. So the solution for number 12, when you end up with a true statement, 0 equals 0, is that x comma y is such that 3x minus 2y equals 5. That is, in fact, there's an infinite number of solutions. The equations are the same. Now, we could work these out. We're not going to give you anything this difficult. And I see the tape is getting long already. So let's see what else we might do to be sure we cover everything. No, the rest are just straightforward and a challenge. Again, you want to know the graphing method, the substitution method, and the elimination method. And you'll have that in your practice. Remember, we have one more section to cover before we have our test. There's only 3 sections in this chapter, so you want to be sure to stay, again, on task. We'll be doing this in our next lesson.